Hi, I'm Greg Epple, and welcome to MGT 302, What's New with Observability at AWS. I'm a principal solutions architect that works within the business development organization, and I focus on DevOps and management services. So today I'm going to talk to you about a lot of new features and functionality that we have across the whole set of observability services, and this includes CloudWatch, X-Ray, Managed Prometheus, Managed Grafana, and our AWS distro for OpenTelemetry. Now, before I go into those specific services, I want to talk about observability in general, because there's been a lot of investment from us in these different services and different features and functionality. And it sometimes can be confusing. What does all this stuff do? But we can basically boil it down to some really simple operational steps, right? If you've ever been in an operations role, you've been an SRE, these should make sense to you. So when we're faced with an event and we're trying to get through and figure out what's gone wrong, what we need to do is, first of all, start with detection. We need to have tools available to help us detect quickly when an event starts. And the detection may not always happen as soon as that event starts. So it's an important reminder. Just because you were alerted doesn't mean that issue had just started then. It could have started 10, 15 minutes ago. So you want to be able to detect these things as quickly as possible, and then move quickly and efficiently from that detection into an investigation stage. This is where you spend most of your time. And then after that, you want to move in and get into this, remediate the underlying issue here. So whenever you've faced, if you've been in an operations role, you've gone through this, I'm sure. It's really important to get through this quickly. And this is where observability comes in. A lot of folks will talk to me and ask, Greg, can you define monitoring versus observability? Is observability replacing monitoring? And the mental model I would use is, think about observability as a property of a system. Monitoring is what you do to collect logs, metrics, and traces. And if you can do that effectively, if you can monitor your systems effectively, that will lead to observability. And why is that important? Well, an observable system is much easier to understand, and that will help you in the detection, the investigation, and ultimately the remediation. So really the goal here of observability is helping you increase availability of your application, decrease MTTR, the mean time to resolution, and get through events as quickly as possible. So let's dive a bit deeper into this and talk about how we actually support observability on AWS. And you could think of the foundation of AWS observability as being built on three things. So we have metrics, right? Metrics are useful for identifying trends, modeling, and prediction. Again, no surprise, these have been around for quite some time. I think most folks know what they are. We have logs as the second component, right? Logs are also obviously very useful. Really, they provide a lot of rich context. Logs are generally slower than metrics. Metrics are usually quite fast, but logs provide you with a lot of context. And then the third piece, which is a bit newer, I think for some folks, is traces. And traces are really, I would say, quite a bit different than metrics and logs. Traces effectively capture the flow through a system. They're very user-centric. A metric and a log is very system-centric or component-centric. A trace is really capturing what a user is doing, what a user is experiencing. So foundationally, when we build new features and services focused on observability, we're looking at our mental model, our foundation to this are these three things. And more importantly, or what we're trying to aim to get towards, is the ability to actually do these effectively, efficiently, and then correlate them. The correlation of metrics, logs, and traces is a really important thing that a lot of folks try and do to help decrease the MTTR and increase availability. Now, if we take this foundation, the other mental model I want you to think about is how we actually what the mental model of how we build upon this foundation, where the areas of focus for us. So the first is infrastructure, right? And again, no surprise that a lot of folks do this. I don't think this is a surprise to anyone, but we have multiple agents that help you monitor what's going on inside of a container, inside of an operating system, inside of your VMs, even process level monitoring, running in your workload. So infrastructure monitoring, not new, but still very, very important. Then we have AWS services, or what we call vended monitoring. And so a lot of services will send their metrics or logs to CloudWatch, as an example, and other solutions can pull those metrics out of CloudWatch and actually visualize them in their solutions. So vendor monitoring plays a really important part. The other area of focus for us, and we'll talk a little bit about this later, is on the tracing. And so this largely comes from X-Ray, and then the profiling from CodeGuru. And I'll talk about how OpenTelemetry fits into this. But application performance is really, really important, big focus for us as well. And then the last area is this end user monitoring. And so today that includes synthetic monitoring, and we'll dive a bit more into how you actually do this through a demo. But we support Selenium and Puppeteer as two of the underlying scripting languages to create your scripts, to create your canary tests in your application. So if we want to, the way to kind of think about this and there's CloudWatch, there's X-Ray, as I mentioned earlier, there's Managed Prometheus and Grafana and OpenTelemetry, the AWS distro for OpenTelemetry. And obviously we have a very rich partner network. So the way to think about how this all maps together is look at those 4 areas of focus, right? Those are built upon that foundation of metrics, logs, and traces. And we have options for AWS native and we have options for open source, right? So on the AWS native side, a lot of customers have a bias to evaluate native services first. And in that case, CloudWatch plays a really important parts in all 4 of these categories. And then we have other services like X-Ray, as well as Amazon CodeGuru, that also contribute to this overall AWS native observability. And then on the open source side, you're seeing a big investment from us. And so in terms of like infrastructure monitoring, AWS managed service for Prometheus, or AMP, as a short name and acronym, or Amazon managed service for Grafana, or AMG. Those 2 services play a big part in this infrastructure monitoring. Then we also have AMG, our managed Grafana service as well, able to pull metrics from CloudWatch, so all those vended metrics. And then the AWS distro for OpenTelemetry is, and we'll dive deeper into this, is a very important piece of our overall tracing strategy. And it really helps us provide an open standard for you to collect your traces in an open standard and then send them into X-Ray. And then a very rich partner network. Again, I wouldn't have enough real estate to put all the logos on here, but I think many of the big names here as well that can help provide a partner-based solution as well. But this is the mental model you should think about in terms of what does observability mean on AWS? What does that mean for a native solution versus an open source? You got how to pick these. I would just say, look at your organization. If you have a bias towards evaluating AWS native first, or you have a bias towards open source, we can support you. So let's dive first into Amazon Managed Service for Prometheus, or AMP. So there's several challenges in a self-hosted Prometheus. The first one being managing storage, API availability, and scalability. When Prometheus was first created, it wasn't built to scale. There was a project that came along called Cortex that would help you deploy this in a distributed fashion. But we hear from many, many customers that they love to use Prometheus, but they don't like to have to manage it. There's just a lot of headache that comes along with having to manage this. So engineers are spending a lot of time, optimizing this, the memory, compression, storage, to try and reduce costs and improve the query response time. So there's a lot of work just basically in maintaining these servers, right? In terms of patching and upgrading the servers, as well as implementing governance policies, as well as for querying and collecting metrics. So what Amazon Managed Prometheus, or AMP, does, it's a serverless Prometheus-compatible monitoring service for metrics to securely monitor. Primarily, a lot of folks will use this to monitor container environments at scale. And I'll do a demo to show you how easy it is to walk through and to actually set this up. You can deploy this in a fully managed, secure, and highly available deployment using multiple AZs. It uses the same open source Prometheus data model and query language. So whatever you're using today on premise or self-hosted on EC2 with Prometheus, very easy to move over to an Amazon managed service for Prometheus. And there's no upfront investment basically required to use the service. And users only pay for the number of metrics ingested. Again, we can help. It gives you provided scalability, availability, security, all the things you come to expect basically from a managed service from AWS. So let's go into the setup, and I'll do a demo in a bit that shows you actually how to set this up. The overall configuration architecture here. You have your collectors, and there's a variety of collectors out there, right? There's OpenTelemetry collectors. We have our own distribution of OpenTelemetry. And you have other Prometheus servers that can basically, through HTTP APIs for remote write, can send the metric, the telemetry to AMP, to the AMP workspace. And then we have our ingester and the query language here. And then we have other, on the read API side, we have other services like Grafana that can pull the metrics and visualize those in Grafana as an example. We've also exposed some of the API and access control. So just a highlight of some of the HTTP APIs like remote write, query metrics, get labels, get series, get metric data. So these are all things that we can then control through IAM roles. So just give you an example of some of the actions as well on the data plane, and there's some things on the control plane as well. So let's go into the use cases here. So for AMP, this is really for folks that want unified container monitoring. They want to troubleshooting or root cause analysis, or any sort of workload and application metric monitoring. One other area that Prometheus and AMP is particularly useful in is high cardinality metric monitoring. And what I mean by high cardinality, I mean lots and lots and lots of metrics. And so those are the primary use cases we see folks using here for AMP. Now, the other service, which was released in conjunction with AMP, is the Amazon Managed Service for Grafana, which I'll just call AMG. So AMG, if you're not familiar with Grafana, Grafana is an open source project that is very, very popular. It's been around for quite some time, has a lot of third-party data sources, and there's a lot of investment from our customers that we've heard that they've invested months, if not years, into building very sophisticated dashboards, and it's become one of really the most popular operational dashboard technologies in the world. This is a very, very popular service. And so Amazon Managed Service for Grafana, very similar to Amazon Managed Service for Prometheus, is really a fully serverless service. You don't even need to provision a cluster or say, I want this size of a cluster. You simply provision a workspace, and you get started. So it's scalable, secure, highly available, fully managed Grafana service. Automatically scales for you. Again, you don't have to specify any sort of cluster size. It will just simply scale. It'll analyze, monitor, and alarm across multiple data sources. And when you use the managed service for Grafana, there's stuff that we do behind the scenes that make it really simple to use, say, organizations, and to add all those accounts easily and directly into the Amazon Managed Service for Grafana. I'll show you a quick demo of how that actually works as well as native integration with other AWS services such as TimeStream, IoT Sitewise, X-Ray, and CloudWatch Logs as an example. And then there's an easy upgrade path to Grafana Enterprise from the AWS Marketplace when it goes into general availability. It's currently in preview right now. And simple pay-as-you-go pricing. Again, like I said, some of the data sources, the popular data sources here are Amazon CloudWatch, which has been around. We've contributed to our CloudWatch plugin for quite some time with Grafana Labs. We have X-Ray integration. It also can integrate with Elasticsearch, TimeStream, IoT Sitewise, which is a new plugin, and there's a new alert destination for Amazon SNS, and then a very rich set of other plugins here as well. So on the use cases, what we're targeting here is really folks that are looking for unified observability, container monitoring. So if you are using Amazon Managed Prometheus or your own Prometheus, is hooking this up to Prometheus and using this to visualize the telemetry that's coming off your containers. One dashboard for everything. So you can combine and join a bunch of different data sources onto a single dashboard. Helping you, again, troubleshoot operational issues collaboratively, IoT monitoring, and software development lifecycle monitoring as well. So again, you can use this separately from Amazon Managed Service for Prometheus. It was also launched at the same time, and there's a very nice integration between those two, but they are separate services as well. So you don't need to be using Prometheus or AMP to use AMG. You can use AMG standalone, but if you do use both, very nice integration I'll walk through in a bit in my demo. The last recent addition from the observability teams here is the AWS distro for OpenTelemetry. So I'll talk a bit about what OpenTelemetry is, and then we'll go into a bit more detail in our distribution. But OpenTelemetry is basically it's a Linux Foundation Cloud Native or CNCF open source project. And its mission, basically, its stated mission is to provide libraries, agents, and other components to really comprehensively unify monitoring, managing, and debugging applications. It captures metrics, distributed traces, resource data, and logs from applications and services, and then can send that captured data to backend things like Prometheus, Zipkin, Jaeger, and X-Ray as well. And so this is used as an open standard including the OpenTelemetry specification and the W3C tracing context specification. So some of our contributions, I want to be very clear, we haven't forked OpenTelemetry. We are a big contributor to OpenTelemetry. We've contributed a lot back. And our distribution is a direct implementation of the standard. So some of the things that we have done is we've been enhancing the open observability standards and contributing software components back to the project. And so some of those contributions include specification enhancements for metric support, C++, C++ metric, API and CDK, JavaScript SDK support for X-Ray. We built an X-Ray receiver, a Java auto instrumentation support for X-Ray, Amazon ECS container metric receiver, as well as a Prometheus remote write exporter. So a lot of folks are asking, well, why AWS distro for OpenTelemetry, right? There's really two challenges. The challenge here is that developers are currently using a lot of very vendor-specific SDKs and agents to instrument their apps. And you even see this on the X-Ray side, right? We have the X-Ray agent, we have X-Ray SDKs, and that's fine. But a lot of customers are asking for an open standard. And so basically the solution here, OpenTelemetry is the solution here because it creates an open standard where you can then go collect tracing in an open standard, and then you can send it to a backend system in that particular format. So you can use our distro for OpenTelemetry or any other distribution for OpenTelemetry that has implemented the X-Ray receiver and exporter, and you can take that, collect your traces in an open standard, and you go send it to X-Ray, send it to Zipkin, send it to Jaeger, wherever you want to send it on the back end. So the AWS distro for OpenTelemetry specifically, like I said, is an upstream first distro. There's no forking here of the popular CNCF project. This is, I think, really important for a lot of customers. It's certified by AWS for security and predictability. So it goes through, we have a very high bar for security and performance, and we put it through that every release. We go through those processes to make sure it's secure and it's performant. It's backed by AWS support as well, which is, again, a big plus. A lot of customers love this, is that, they can open up a ticket with support, and this will be fully supported, this distribution, by our support organization network. And then we also have one-click deployments and configurations for this from AWS containers and Lambda consoles. And like I mentioned previously, we have exporters for many of the solutions like Amazon or CloudWatch, X-Ray, and the Amazon Elasticsearch service. So at this point, what I'll do here is I'm going to go do a quick demo of how you provision Amazon Managed Prometheus, Amazon Managed Grafana, as well as how you get started with AWS distro for OpenTelemetry.
All right, now we're going to do a demo into Amazon Managed Prometheus, Managed Grafana, and the AWS distro for OpenTelemetry. Before we do that, I want to highlight this workshop that we have at observability.workshop.aws. If you're interested in more of these tools, get more hands-on, deeper dive, the tools that we talked about, and a lot of the other features, say in CloudWatch and X-Ray, that we may not talk about, definitely take a look at this, and you can dive much deeper. But a lot of the demos I'll do here are often based off of this workshop. Again, the purpose of the workshop is to deploy something meaningful, something somewhat complex to an AWS account, so you get a good sense of what the tools are capable of. The front end of the site is a pet adoption website. That doesn't really matter. What matters here is that we have a mix of containers and serverless and a more traditional EC2 or VM-based infrastructure here, as well as a bunch of different languages. So again, highly recommend you check this out outside of this talk here. But the first tool I'll talk about is the AWS Open Distro for AWS Open Distro for OpenTelemetry. And with this, I'm not going to actually show how you go and set up a collector here, but I just want to point out this documentation site here, aws-otil.github.io. This is a wealth of information on how to get started with different scenarios, Docker, ECS, EKS on-prem, as well as other operating systems, and goes through the different components and basically how do you get started based off of one of these languages. So I highly recommend you read through this in detail and use this as your getting started for using our AWS Open Distro for OpenTelemetry. As I had mentioned earlier, our OpenTelemetry distribution is capable of sending metrics into Managed Prometheus. And so let's start there. So I'm going to go into our Managed Prometheus server. I have two workspaces here right now. I'm going to go ahead and create a third, but I'll show you how simple this really is. We'll call this Greg Test 3. I'll click Create. And literally within a few seconds, you're going to have a workspace set up and running. So we'll just give it a minute. I'll switch to Ray here in a second. But what you'll note here is there's an ARN, an Amazon resource name. Now you can see this is now active, so it only takes a few seconds. And so you can, again, as I mentioned earlier in the deck, you can set IAM policies to control permissions to this workspace. So there's your ARN for doing that. And then you have two endpoints, a remote write and a query. So a write and a read. And there's some more information here on how you can enable like an existing Prometheus server to remote write to this workspace. But this is all you need to do to set up a managed service Prometheus. There's no cluster sizing that you have to do. You simply give it a name and then you're off to the races here. Now, Grafana is very similar to that, and I'll show you how these two integrate. So if we go to Grafana, it will take a few more seconds, but it generally will provision in less than a minute. I'm going to go ahead and we'll do Greg Test 3 here as well. It will ask you a few more questions. It will ask you, do you want to use customer managed roles or service managed? I'll go with the default. And then it will ask what data sources do you want to enable? So in this account here, because it's not a root account, it's basically just saying, okay, do you want to enable access to these data sources in this account? If I was doing this in a root account in the organizations, I could basically automatically set permissions to all these sources like X-Ray and CloudWatch in all my child accounts within the organizational structure here. But in this example, I'm just doing this specific account here. And then I can set up the notification channel that I want as well. I'll click Next, and then I'll go and click Workspace. Again, this should take under a minute. It takes a few seconds. So one thing you will do is also you will note that authentication is handled through AWS SSO. So you could take AWS SSO and then actually federate that with another identity provider, and you can use that to log in. So if you have your corporate identity credentials, you can use that to log into here. I'll go into another workspace I already have running here. So when I go into here, you'll see I have one user. Again, this has come from AWS SSO. I made that user an admin, and I'm going to click this URL to log into Grafana. So in just a second here, now normally I'll actually log out and show you what the login experience looks like. So let's do that again. I'll come here and I'll go sign in with AWS SSO. It's now signing me in. It's already kept my credentials, otherwise it would have asked me to log in. And this should just look like, really almost look like any other Grafana that you've used before, with one exception is we've simplified the adding of data sources from AWS. So if I go to data sources here, and I let's go to Prometheus, what you'll see here is you'll see some of the Prometheus workspaces that we've set up. I haven't had to do anything to this Grafana instance. These just automatically got added. And I can go ahead and set, I've already set these up, but I can add additional data sources here as well. So if we go to Virginia, it's going to go fetch more data sources if they exist. So this will just take a second. And then I can go add those Prometheus workspaces there as well. I can also do the same thing. So actually, before I skip ahead there, you can see these are the three data sources I'm able to add. And I could do the same thing for CloudWatch or anything else running in that account or at any region. I can go easily add that without having to manage credentials. So it's very, very straightforward to do this. So I'm going to go ahead and click Add Data Source, and that's basically all I have to do to add my data source. So by using a managed service for Grafana, it greatly simplifies connecting to the managed service for Prometheus, as well as those other AWS data sources such as IoT Sitewise, TimeStream, X-Ray, Elasticsearch, and Prometheus here. So I'm going to go back to my deck here and we'll talk about some of the new features from CloudWatch and X-Ray.
All right, now that I've just shown you AMP, AMG, and the AWS Distro for OpenTelemetry, I want to talk about some of the recent releases from CloudWatch and X-Ray, and then we'll do a quick demo of those as well. So some of the recent things that we've launched in the last several months are CloudWatch Lambda Insights. So this is an observability tool to give you more insight into how Lambda is operating, allows you to dive deeper and right size your Lambda function and dive really, really deep into the performance and the execution of your Lambda functions. The ability to do dashboard sharing in CloudWatch, so you can externalize your dashboards outside of your organization through a variety of mechanisms, as well as CloudWatch Metric Explorer, which is a really fascinating service. One of my favorite services is the ability to slice and dice metrics by different dimensions, and then you can throw that onto a CloudWatch dashboard actually as well. But for when you have a lot of tags that are driving your infrastructure, and then that infrastructure or those resources are sending metrics, you can then use the tags in Metric Explorer to slice and dice how you visualize those metrics, as well as X-Ray Insights, which is an anomaly detection powered feature within X-Ray that helps you do root cause analysis very quickly. And then CloudWatch Synthetics has had several recent releases here as well that we'll touch on, but Selenium support, Python and Selenium support. We now have a Chrome recorder in the Chrome store, so you can go without having to learn Puppeteer. You can go ahead and just go run that recorder and navigate, and it'll generate a script for you, as well as X-Ray and API support as well. So, what I'll do here now, I'm going to actually switch back and I'll go and do a quick demo of some of these features.
All right, so now let's do a quick demo of some of the newer services and features from CloudWatch. So I'm on the CloudWatch page right now. The first thing I want to highlight is some of the recent releases for CloudWatch Synthetics, which is our synthetic monitoring service. So one of those things is the ability to write your tests or create your canaries using Selenium. Selenium is a very popular open source project. A lot of folks have invested many years into writing Selenium tests and monitoring scripts. So we now support Python and Selenium, so you can go ahead and use those. And we still support Puppeteer, which is what we launched with. On top of that, what we've also launched is a browser-based plugin for Chrome. So you can see that we have a series of blueprints here, right? If you have a heartbeat monitoring that you want to do, you can just load in a simple page, a URL. We'll load up that page, take a screenshot for you, and put the results into Synthetics here. Or you can do things like broken link checkers, where we'll crawl a number of URLs under that first URL. But a lot of folks want to use a UI-based experience for creating their scripts. And so that's where the Canary Recorder comes into play. So I've already installed this, but it's available in the Chrome store. And so I'm going to go ahead and click New Recording. We'll click Start. And I'll go to the workshop I talked about. And I'll just click around a few things here. You can imagine I'm trying to simulate some sort of user flow through a website. And what I'll do here now is I will go ahead and stop the recording. And I'll have a script that I can then directly copy to my clipboard, go into Synthetics, and I can go ahead and copy it directly into the script editor, and I have my script. I haven't had to write a single line of scripting here or code. I've just generated this by doing a bunch of actions as a user, and then it will go and do this itself. It actually runs this canary here. And so the other thing that I do want to highlight is that if we go to create canary, if you're using API Gateway, we've recently released an integration with API Gateway. So when you go and create that canary, you can say, I'm using API Gateway, and you can actually just go ahead and start choosing the API and the stages from API Gateway here. We've simplified the integration into API Gateway and Synthetics here. So that's also something you definitely should check out if you are a user of Amazon API Gateway here. Some of the other features that we call out in the deck are Metric Explorer, or the ability to really, I would say, slice and dice the data, the metrics that you have, the telemetry. So if I go to here, I'm going to select this generic template I have for Lambda. But effectively, what it allows you to do is select a series of metrics. I'll just go down to duration. And what this will then do is allow me to apply tags as a kind of a filter in the from. So I can look at resources based off their tags and properties. I'll just leave that empty for now. I can also choose to do aggregations. So I can say for each of these boxes, I want to do some sort of aggregation, like an average, and I'm going to do it across all resources, or I can do multiple aggregations by different dimensions here. So I'll just say all resources, and then these boxes are created by a split. So I've selected something to split this, in this case runtime, and it's going to go and actually create a box per runtime that's actually running here. So you can imagine for any sort of set of metrics like Lambda, like EC2, or any of these other services, you can often do a lot of tagging. There's a lot of properties that you may want to view the metrics through that lens. So Metric Explorer lets you really easily slice and dice this data on a nice visualization. And you can actually go and add this to a dashboard here as well. So I can go ahead, I have this existing dashboard, I'll add to it, and we'll save it. And I have my individual metrics here, but I have my Metric Explorer as a dashboard component here, and I can go ahead and edit those values here. So it adds a lot more dynamicness to the dashboarding. One of the last things I do want to call out is Lambda Insights. So this was another new feature that we launched for CloudWatch, and it's really provides you observability into Lambda. So I can look at multi-function or single function. I'm going to go ahead and look at this specific Lambda function myself. And so again, I'm getting information like invocations, errors, the duration, the P50, P90, P100, network usage, throttling. I'm also seeing a list of the 10,000 most recent, or sorry, the 1,000 most recent invocations, and giving information about how much network I/O occurred, CPU time, memory, as well as tracing. So I have tracing set up, and so I can go into an individual trace here. And I'm not seeing a trace for every single Lambda call because I'm sampling my traces. But I can go into that trace, and now I'm seeing the individual data, the trace data for that specific Lambda that Lambda function was in. So I found the trace that Lambda function participated in, and I can go in and dive in and understand what else was occurring when that Lambda function was invocated. So I can see here, you read these from left to right. Customer hit this container, which talked to another container, which talked to this remote API or URL, which also talked to this API gateway, which then talked to Lambda. So this is where Lambda is getting invocated. This whole thing took 1.1 seconds. Again, this is the power of trace, is that I can quickly see on the timeline how sequential, how parallel is my code. Why did that take 1.1 seconds? And I can very quickly identify a root cause that. As well as I'm getting information about each of these segments down here, so I can click on a different segment like a container, get information about that, or DynamoDB. I'm also doing correlated logs. It's also correlating the logs here. So this is really going back to what I said earlier about foundationally observability supported by metrics, logs, and traces. And this is a great example of showing you how you can actually combine those three things together and automatically do that correlation, which is what truly will give you observability. So let me go back to my deck.
All right, so I've done a quick overview of all the recent big launches that we had at reInvent, as well as new features in CloudWatch and Xray. I do want to just highlight some of our other areas where you can learn more about these services and observability in general. We have lots of digital training available, classroom training. We obviously have our certification program. So please go to the URL down there, the training site. There's a lot of information and great material and content to learn more about these services. I want to thank you for listening to the session, and just a quick reminder to please complete your session survey.